Hi everyone. So this is Unit 1, Lesson 4, Solving Linear Systems by Elimination. So this is the third technique that we're going to be using to solve linear systems. And you might be wondering, well, I already have two techniques. Why do I need to learn a third one? Because you can solve all of the problems that I'm showing you today, you can solve all of them by graphing, you can solve all of them by substitution. So why bother learning something else? And the answer is, well, there are a bunch of reasons, but I can think of two major reasons. Sometimes using this method is easier, but also this is a really important method if you move further ahead with math. If you actually take linear algebra in university, you're going to be using a slightly more complicated version of this method to solve more complicated linear equations. Linear systems, to solve more complicated linear systems, that substitution gets kind of doesn't work so well. So learning how this method works is pretty important for your understanding of mathematics. Okay, so what we're going to be doing here is we're going to be solving a linear system by elimination. So we're going to learn how to do that. Check your solution. There's not much else to say here. This is the same as it's always been, so hopefully that's review. And for elimination, identifying cases where there are infinite solutions or no solutions. Really, you only have one extra learning goal here because these two are the same as something that you've seen before. So left side, right side check, same thing as before. And it turns out that when you have infinite solutions or no solutions with elimination, it looks exactly like it looks like with substitution. Okay, so we're going to solve the following elimination system by elimination. So this one, I've used some numbers that are not as nice just to get you used to doing a bit of fractions here. So we have 3x plus y equals 18, 2x minus y equals 15. So to solve a system by elimination, what we do is we eliminate one of our variables. That's why we call this elimination. And the way you do that is by taking these two equations and adding or subtracting the two equations together. So that looks something like this. So I write my two equations one on top of each other, and I can add them or I can subtract them. And what you'll notice is that if I add these two equations, I have plus y and I have minus y. Plus y and minus y, if I add those together, I get 0. The y's eliminate. So this is a nice set of equations to use elimination with. This is one of those cases where elimination is probably easier to use than substitution. Okay, so what do I mean when I say I add these two equations? Well, I take everything on the left side and I add them together, and I take everything on the right side and I add those together, and the equal sign just drops below. So you can see here my equal sign, I just continue that below, and everything on this side gets added together. So 3x plus y plus 2x minus y. And I have all four terms here. I've just rearranged them a little bit to make the addition easier. So I have 3x plus y plus 2x minus y. I rearrange that. So now I can do my y minus y. So y is eliminated. That becomes 0. And I have 3x plus 2x is 5x. On the right-hand side, I have 18 plus 15, which is 33. Unfortunately, 33 can't be divided by 5 evenly, so I divide both sides by 5, and this is left as a fraction. So x is equal to 33 over 5. Yeah, it's kind of ugly, but sometimes that's the way it is. Okay, so now the problem looks pretty much the way it does when we did substitution. We take our value for x, and we put it into one of these two equations. So I'm going to put it into the second equation. Really doesn't matter. So 2x minus y equals 15. I know what x is, so I'm going to replace x with 33 over 5. Remember that when you're multiplying fractions, this 2 is kind of like 2 over 1. So 2 times 33 is 66. 1 times 5 is 5. So I get 66 over 5 minus y. I bring the 66 over 5 to the other side, so it becomes negative. And I have a negative y on this side, so I divide both sides by negative 1, and that changes the sign for everything. So negative y becomes positive y. Negative 66 over 5 becomes positive 66 over 5. And 15 becomes negative 15. All right, so I'm going to do some subtraction here. If I'm going to subtract, I need to find a common denominator, and remember that this is 15 over 1. So if I'm going to take 15 over 1 and put that over 5, I have to multiply the bottom 1 by 5, and the top 15 by 5. So I get 66 minus 75 over 66 over 5 rather, minus 75 over 5, and so I get my answer of negative 9 over 5. And so that's my value for y. So that's it, 33 over 5, comma, negative 9 over 5, or I can just say x equals 33 over 5 and y equals negative 9 over 5. So you can check your work for that one if you want to. I've left that up to you in this case. All right, we're going to get a little bit more complicated here now. We are going to solve this system of equations by elimination. And this is a little bit more complicated because nothing eliminates if I just add these equations together. Right, if I add them, 6x plus 3x gives me 9x, 3y plus y gives me 4y. I have 9x plus 4y. I haven't eliminated x or y. So I can't really just add these two. That's not going to help me. So what you have to do is modify the situation without really changing the equation. And remember, the way that you can do that is you can do something to an equation as long as you do the same thing on one side and the same thing on the other side. You're not really changing what the equation means. So I can do that, right? I can change these numbers as long as whatever I'm doing on my left side, I'm doing the same thing on the right side. Okay? And what we're going to be doing is either multiplying or dividing numbers. So what you might notice here is that we have 3x here and we have 6x there. If I multiply the bottom by negative 2, then this 3x can become a negative 6x. And that's kind of what you want. If you can have some number x and the same number here but negative, when you add them together, they'll eliminate. You might be saying, well, okay, fine, yeah, I could multiply 3x by negative 2 to get negative 6x, but what about here? Couldn't I just multiply by negative 3 and get negative 3y? And the answer is yes. So there's more than one way to do this kind of problem. I'm just going to do it with the 3x here multiplying by negative 2. So I take this whole equation, 3x plus y equals 10, and I multiply both sides by negative 2. So remember, you have to distribute. So the negative 2, if I'm multiplying the left side rather, by negative 2, I multiply the 3x and the y both by negative 2. And then I also have to do the same thing on the right side, right? I have to do that or I'm changing the equation. So negative 2 times 10. And so then I get negative 6x minus 2y equals negative 20. So everything got multiplied by negative 2. And now that makes things nice and easy because I have a 6x here and I have a negative 6x there. If we add the two equations together, they will eliminate. So same thing as I did before, 6x plus 3y plus negative 6x plus negative 2y. I add up the entire left side, and you're going to see that my 6x and negative 6x will eliminate each other. I also have to add everything up on the right side, so I get 9 plus negative 20. And when I simplify everything algebraically here, I'm going to end up with y equals negative 11. So now you've done elimination, and you're going back to the same thing that we did in the substitution lesson. Once you have one of your variables, x or y, you take it and you plug it into one of the equations that we have here. So I have y equals to negative 11. I'm going to sub that into the first equation. Probably it would have been easier for me to sub it into the second equation, but whatever, it doesn't matter. So I have 6x plus 3y equals 9, so that's one of my original equations. I'm going to put negative 11 in for y, 6x plus 3 times negative 11, and that allows me to solve for x, right? So negative 33, bring that over to the other side, and I get 42. Divide both sides by 6, x is equal to 7. So I have 7 comma negative 11, or in other words, x is equal to 7, y is equal to negative 11. I have the solution here. All right, so example 3 is the most complicated type of question you're going to get, because what you're going to notice here is that there is no easy number that I can multiply either equation by to get a case where I have, say, for example, a 10 and a negative 10, or a 4 and a negative 4. Right? If I want to multiply something by 3 to get to 4, that's going to be a fraction. That's going to be 4 over 3. If I want to multiply something by 3 to get to 10, again, that's going to be a fraction. So if I don't want to use fractions, this question is kind of annoying. But there is a workaround. And the workaround is you can multiply both equations by a number. Okay, so what I'm going to do here is I'm going to multiply the top equation by -3 and the bottom equation by 4. So how did I know to do that? And the answer is you're basically doing something similar to when you're finding the common denominator of a fraction here. You're finding the lowest common multiple. So I'm going to choose y because the numbers 4 and 3 are lower numbers, and so that makes it more likely that I'm going to have an easier time finding a lower common multiple than I would, say, with 3 and 10. So what's the lowest common multiple between 4 and 3? Well, that's going to be 12, right? 4 times 3 is 12. Remember that when you're finding a common denominator, if you can't find the lowest common multiple, just multiply the two numbers together, 4 times 3. That does actually give you the lowest common multiple in this case. So 4 times 3. So what that means then is if I multiply the top equation by 3 and the bottom equation by 4, I'm going to get a 12 here and I'm going to get a 12 there, and then they will eliminate. So I can multiply the top by 3 and the bottom by -4, or I can multiply the top by -3 and the bottom by 4. As long as the signs are opposite, then I'm going to get a 12 and a -12, which will eliminate. Okay, so I've multiplied the top by -3 and the bottom by +4. Again, remember that you have to multiply both the left and the right side by -3. So it distributes, and that ends up with -9x minus 12y equal to -36. For equation 2, I multiply both the left side and the right side by 4, and I get 40x plus 12y equals 160. And again, notice here you now have -12y, +12y. If you add these two equations together, they will eliminate y. So that's what we do. We add these two equations together, and we end up with 31x is equal to 124. It turns out that 124 is divisible by 31. You get x equals to 4. And so, again, you're done with elimination, and you just take that 4 for x, and you sub it into either one of these equations. You can use the new equations that you made here if you want to, the 40x plus 12y equals 160. If you want, you can go back to your original equations. It doesn't matter. All of those equations should give you the same answer. So what you do then is you put x equals 4 into the original equation. That's what I've done here. 3 times 4 is 12. We bring the 12 over to the other side. You get 4y equals to 0. So y equals to 0. Okay, so then we have our x, we have our y. So our solution to the system is 4, 0, or x equals 4 and y equals 0. Okay, so just to end off here, remember that if you have a situation where you have infinite solutions, when you actually do this part here, instead of getting x equals 4 or something else, you're going to get 0 equals 0 if you have infinite solutions. If you have no solutions, you will get you will get 0 equals to some other number, like 0 equals to 1, or 0 equals to -7, or something that doesn't make sense. So that will tell you that you have no solutions. So that's exactly the same as it would be in substitution. Okay? So the only new thing really that we're doing here is learning the elimination method. And then half of this method is basically the same as substitution anyway. Okay, so at this point you should know how to solve a linear system by elimination. And the other two things you'd already learned. I've included another video below here, which will give you a worked example if you want to see that. And so that's pretty much all that we have here. Again, I might not have said this in the other videos, but I hope that I've mentioned this to you somewhere before. Please make sure that you practice these techniques. If you think you're following along and you think what I'm saying makes sense, you might find that it's a different story to actually try and do the question on your own, right? Once you try and do it on your own, you might find it's a lot harder. Or maybe me rambling and talking doesn't really work for you, and this is kind of just going in one ear and out the other. In that case, you're really only going to learn by doing the questions anyway. So please make sure that you practice all of these questions. Thank you.